Hey, Assalamualaikum and salam sejahtera to all viewer and to my lecturer Puan Bahira. Okay, so today me and my partner will explain about the Lorentz Law and the Fleming's left-hand rule. So, welcome to our presentation. Let's go. Okay, before we start, let me introduce myself. My name is Muhammad Faisal bin Muhammad Fauzi, and my partner is Hafiz Daniel bin Muhammad Nazri. So, in this slide, I will explain about the Lorentz Law, and my partner will explain about the Fleming's left-hand rules. So, let we start. Let's go. Force. In physics, the Lorentz force or electromagnetic force is the combination of electric and magnetic force on the point charge due to electromagnetic fields. A particle of charge Q moving with a velocity v in an electricity field that E and a magnetic field B experience a force of this equation. This equation. Okay, so pengasas untuk Lorentz force ni adalah Henry Anton Lorentz. Dia orang pertama yang mencipta formula ini. So, dia lahir pada 18 Julai 1853 di Netherlands, Belanda. Dia meninggal pada 4 Februari 1928 pada umur 74 tahun. So, okay, jom kita terus KI. Okay, let me. Somewhere other charge and current have generated an electric field and magnetic flux density. These fields are exert a force on charge Q equal to F equal Q divided by ER plus VX BR. Okay. Here, the force due to ER could be parallel to velocity vector. Okay. Yeah. Okay. For that case, ER we apply a force on the charge in the direction of its velocity. This will speed up the charge, essentially adapting kinetic. This is the velocity, and this is the Fe. Next point. All the force due to ER, it could be anti-parallel to velocity vector U. For this case, the electric field apply a force on the charge in the opposite direction of its movement. This will slow down the charge exactly extracting. So it another direction. So you look this V direction to here, and this V direction to, so it anti direction. Okay, so now contrast this with the force applied by the magnetic flux density. We know that Fm, okay, here equal to Vx BRQ. Therefore, the force the force Fm is always orthogonal to velocity. As the result, the force due to the magnetic flux density can change the direction of velocity u v, but not the magnitude of the velocity v. In other words, the force Fm neither speed up or slow down a charged particle, although it will change its direction. As a result, the magnetic flux density Br cannot modify the kinetic energy of the charged particles. So, practice application of Lorentz Law. And a most perfect application of the Lorentz Law is the cathode ray tube (CRT), the device at the heart of every television and computer monitor, or at least the non-plasma or LED. So I want to share you about the video, uh, more about the Lorentz law. So let's go check this out.
Which is made up of negatively charged particles or electrons moving through a wire. Shown here as yellow particles, electrons move from negative to positive. However, the convention is to think of electrical current as moving from positive to negative. So that's how we'll show it here using red particles. If it's not moving, a charged particle doesn't create any magnetic field. But when it moves, it generates a little magnetic field around it, shown by these green arrows. Flip the direction of the current, and you flip the direction in which the magnetic field circles around it. The magnetic field produced by the current will interact with another magnetic field, just the way two magnets repel or attract each other. Here's a horseshoe magnet with a north and south pole. The magnetic field always points from north to south, as shown by the blue lines. This wire is arranged in a kind of pendulum, so it can swing back and forth. Let's insert the horseshoe magnet into this setup and see what happens when electricity runs through the wire and creates a magnetic field around it. The pendulum swings in a different direction perpendicular to the horseshoe magnet's field and to the movement of the current, causing, in turn, the pendulum to swing in the opposite direction. Flipping the horseshoe magnet around to reverse the magnetic field around the pendulum also cause the wire to swing in the opposite direction. The Lorentz force is what makes our electric motors work. Without this force, our modern world would be quite different.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afidaniel bin Manazri. My metric number B0820103996. Today I want to explain how Fleming's left-hand rule works. So first of all, it is possible to predict the direction of the force acting on a wire is motion if the direction of the current or the magnetic field are known. Fleming's left-hand rule is used to do this. This is thumb, and this is first finger, magnetic field, and single finger is current. So you can see on the slide, this is thumb equal to motion, first finger equal to magnetic field, and second finger equal to current. So secondly, force in a magnetic field equation. As you have just seen, the size of the force depend on V magnetic flux density, I equal to current in the wire, L equal to length of the wire. And this is a formula for the force. Force equal to magnetic times current times length. And if the field is not right angle to the wire, then the perpendicular moment of the field is used, and the equation is force equal to magnetic flux times current times length times sin theta. Okay, this is force in the magnetic field alternative equation. All of this formula is a alternative equation to find a force. There's four formula to find a force. So the slide is force on a current carrying conductor in a magnetic field. To explain this, the force exerted on the wire, we need to consider the combined magnetic field due to the current flowing through the straight wire and the magnet. This is field due to magnet, as we can see, north to the south, and this is current into the wire. Force on a current carrying conductor in a magnetic field. Okay, the wire moves because the magnetic field of the permanent magnet react with the magnetic field of the current in the wire. As you can see, north to the south, but direction of the force left to the right. Okay, the two fields acting in the same direction combine to give a stronger field, but the two fields opposing each other combine to give a weaker field. For example, like this. This is a two field opposing each other to weak the field of magnetic. Okay. Hence, the unbalanced field on both sides produce a force that exerted on the wire. This is a stronger field and this is a weaker field. Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Daniel bin Muhammad Nazri. My metric number B0820103996. Today I want to explain how working principle of DC motor. Okay, yang ini adalah no pole, yang ini adalah south pole. Yang ini adalah current carrying conductor. Yang ini adalah magnetic field yang menghala ke kanan. Yang arrow ni adalah force. So kita boleh lihat bagaimana pergerakan magnetic field tu bergerak. Okay, yang ni adalah north pole. Yang ni adalah south pole. Yang ni adalah armature. Okay, armature dia bersambung dengan bekalan elektrik DC. So apa yang kita boleh lihat, yang ni adalah brushes, yang ni adalah commutator segment. So kita boleh lihat current mengalir daripada positif menghala masuk balik ke arah negatif. Okay, Fleming's left hand rule. So macam mana kita nak tahu? Gunakan tangan kiri. Yang ni adalah magnetic field. Yang ni adalah direction of current. Yang ni adalah mechanical force. So ni mechanical force, magnetic field, direction of current. Okay, kalau berdasarkan video tu, kita boleh tengok magnetic field dia menghara ke sana. Kalau daripada sini video. So arrow putih tu menunjukkan magnetic field daripada north ke south. Current adalah menunjukkan di mana current tu mengalir. Dan mechanical force tu menunjukkan arah putaran armature. So kita boleh lihat current magnetic field mengalir daripada north pole ke south pole, dan current bila positif mengalir balik ke negatif. Arrow merah ni adalah mechanical force, arah putaran dia, arah putaran armature. So sama seperti tadi, yang arrow putih ni adalah magnetic field daripada north pole ke south pole. Arrow kuning ni adalah current daripada yang mengalir daripada positif ke negatif, dan arrow merah ni adalah mechanical force. Itu saja penerangan daripada saya. Sekian, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.